Nerdinas, so today we will be beginning the first experiment. So this video will show you everything that you need to get the 3-bit LED counter functioning and working, including everything that you'll need to solder on in terms of components and also the program. So the 3-bit LED counter, you have 3 LEDs that count in series from 0 to 7, and every 1 second the number that the LEDs are displaying changes. And after the LEDs get to 7, they reset back to 0 and start all over. And this is a super useful experiment because in any electronic clock or timer device, you have a similar setup because you need something that can keep time. So in this experiment, we'll be learning in general how clocks and timers work.
So the first experiment is a 3-bit LED counter, and I will insert a video of what that experiment does right here. For the LED experiment, you're going to need 3 LEDs, 2 capacitors, 1 crystal oscillator, and 3 resistors. So you want to begin by identifying the positive and negative side of your LEDs. So I have an LED right here, longer lead positive, shorter lead negative. Okay. So the first step is going to be to solder on your 3 LEDs and then connect the positive side of each LED to a resistor. And then each resistor, I'll bring out the pinout sheet right here, and I'm just going to place the board right there. So the first LED is going to be connected to RC0, the second LED to RC1, and the third LED to RC2. Next, you're going to take your crystal oscillator right here, and you're going to place 2 capacitors by the crystal oscillator, and these capacitors don't have a positive and a negative, and each capacitor is 0.1 microfarads. So you're going to take 2 capacitors, and you're going to have 1 capacitor for the positive side of the crystal and 1 capacitor for the negative side of the crystal. You're going to want to make sure that the resistors and the LEDs are connected and the capacitor and the crystal and the oscillator is connected. You're going to want to wire from one part of the oscillator to pin 13 and the other part of the oscillator to pin 14. And if you look at the diagram over here, you can see that pin 13 has OSC, which stands for oscillator 1, and pin 14 has OSC2, which stands for oscillator 2. So you're going to connect the LEDs, and then the negative side of the LEDs is going to go to ground. And ground is special because the main ground on the circuit is over here, which is this voltage regulator, and it's the middle pin of the voltage regulator, but you can connect these LEDs to any ground as long as eventually ground ends up at the voltage regulator. So in my case, I think I've connected the LED ground to the voltage regulator ground directly. And now showing you on the circuit diagram, you have your 3 LEDs. Each LED is connected to a resistor, 3, 4, 5. Each of these resistors is 330 ohms, and then they lead to pins 15, 16, and 17 respectively. And the negative side of the LEDs goes to ground, so it can go to your voltage regulator ground, or it can go to your circuit's ground, which can then go to the voltage regulator's ground, as long as eventually all of your grounds are connected and they end up right there. Okay, now let's look at the program that we're writing for the LEDs and go over it step by step. So in order to begin the experiments and the programming, you'll need to download a software called MP Lab, and this is programming in embedded C. So once you you will plug your picket in, choose the model that it is, picket 3, choose the microcontroller PIC16F877A, and you will be ready to start programming. Here is the program for the LED. So let's go over it and see what's going on. So here we're defining the frequency, and the crystal oscillator that I showed you before, it serves as a timer for the circuit, and it does this by giving electronic signals at very precise times. So every so often it'll give an electronic signal. So here we're defining the frequency at which a signal is given. So now, in terms of this program, the first thing that we are doing is defining an integer I.
The next thing that we are doing is defining exactly where the LED input is coming from on the microcontroller.
And we have a simple program right here. So basically in this loop, so here we have what's called a while loop. So at any given time, I is continuously being incremented. So now we're changing the number that the LEDs are displaying. So first the LEDs will be displaying the number 0, then 1, then 2, then 3, then 4, then 5, then 6, and 7. And then once the LEDs get to 8, they'll be displaying 0 again.
That is it for the first experiment, and I will see you in our next video with how to do the other experiments. From each Nerdina to all Nerdinas, adios.